Hey everyone, welcome to the video of the recursion. So in this video, we are going to discuss two problems based on the recursion. First, we will print the natural number in the ascending order from 1 to n. And next is, we'll print the natural number in the descending order from n to 1 using the recursive approach. Okay. So if you've not watched the previous video of the recursion, you can find those videos in the recursion playlist, and you can find the link of this playlist in the video description below. So do watch them. Now let's start our video. I hope you know that how to print the natural numbers from 1 to n using the iteration method, right? So let's say we have this main function and we have passed the value of the n by taking from the user, okay? And the function is print. So this function print is printing the natural number, okay, from 1 to n. So we have just used the for loop. You can use any loop, okay? And it is starting from 1 and it is getting updated in step of 1 again and again. So I will be 1, 2, okay, 3 and so on, okay, till n, and then it will be printing the value of I in each iteration, right? And after that it will complete and it will return to the main function. If I ask you how many function call, okay, to this print function is being made in this iterative method, so basically main has called the print function, okay? So let's say n is 3, so print 3 was called, and after that there is no further function call, okay, that can be placed here, right? So only one function call is being made to print, okay? Now if we want to write this code in the recursive manner, okay, and we want to print natural number from 1 to n, how we can write the code? So the idea will be similar, okay? If you have watched my previous video, you will be very easily able to write this recursive code, okay? Basically idea will be same, that if n is passed, okay, then there will be something which should actually print this, you can say, your natural numbers, and there should be something which should stop us from the infinite recursion, okay? Basically in the recursion we will be calling this print function again and again from inside, okay? But there will be some base or stop condition which should stop us from going to the infinite recursion, okay? So that are the two things, recursive function calls and the base condition, that are important in the iterative approach, okay? So as we have to start from the 1, okay, then we want to print 2, then 3, okay? And let's say if n is 4, then we want to print 4 also, but we do not want to print 5, 6 and all, okay? We want to print till n, right? So basically there should be something that we can start with, okay? So let's say we can take I, okay, and it will start from 1, okay, and in the program it will reach till n, okay? So basically we have to again and again print something, okay? We have to again and again do some work, that is printing, okay? We have to again and again print this natural number. So we have actually taken a variable I, okay, which will be actually printing this 1, 2, 3, 4, okay? And initially I will be 1, right? In the next function call it will be made 2, so it will print 2. Then in the next function call it will made 3. Then in the next function call it will made 4, so it will print 4, okay? And when I will cross n, then will not do anything, will just return, okay? So there will be some stopping condition, okay? That means when I actually crosses n, okay, then we will stop, okay? When I is, you can say, less than or equal to n, okay, then we will continue. Continue what? We will continue to call functions, okay? We will continue to call our print function, okay, again and again, okay? And we will actually send I, okay, by updating, okay? You can say plus plus I, okay? We will again call this I with the incremented value, right? So this is, you can say, recursive function call, okay? You have to call these functions, but you have to update the value of I also, okay? You have to change the value of I. So you have to think while you are writing the recursive code, you have to see that if you are passing the parameters, then how you will change the value of the parameters, okay? So that this will help us to reach the stopping condition, okay? And the next thing is obvious, you have to see what is the stopping condition, right? So you have to see the repeated work that is being done in your, you can say, program, okay, that you can do, okay? The repeated work that will be helping us to write the, you can say, recursive function call, okay? So here is the code. So here you can see I have to start the value of I, okay? I have to start printing from I equal to 1. So I have sent the start value as 1, okay? And then what is the limit? Limit is n, okay? So let's say n is 3, right? So basically here you can see now in this print function I have taken 2 parameter. Okay, let's say this is int. Okay, and here you can see this is the stopping condition or the base condition. Okay, and this is the function call. Okay, and in between you can say function call and the you can say stopping condition, we have our work. Okay, this is the work that we have to do. We have to again print I, right? So basically from the previous videos, if you have understood, you will be easily able to understand this. Okay, and here we have to see, we have to pass 2 parameters because this should match with the signature. Okay, here 2 parameters are there, here should be 2 parameters, and each of the function call n value is not getting changed. Okay, this is same, but I value is getting updated. Okay, because we have to change I so that it reaches to n. So here you can see we have this program, right? And now if I run this program, see, let's say n is 3. Okay, so if n is 3, here you can see 1 2 3 are being printed. Okay, and let's say if n is 4, okay, so 1 2 3 4, okay, 4 natural numbers are being printed, right? Okay, so how actually it is working, I hope if you have seen my previous video, you will be easily able to understand it. Okay, and this condition is saying when I will be greater than n. Okay, n is 3, so when I will be greater than n, when I will be 4, okay, then only it will be greater than n, and we will say yes, I is greater than n. We have to return, we do not have to make further function call. Okay, before that, when I is 1 2 3, we will actually come here only. Okay, because that will not be greater than n. Okay, so 1 is greater than 3, no, we'll print this value of I, that is 1, and after that we'll update the value of I, so it will be made 2. Okay, and then comma 3, so basically here also it will be changed to 2. Okay, and print 2 comma 3 will be called. So from here the function call is made. Again 2 is greater than 3, no, so 2 will be printed as such, and then we'll again do the work of printing repeatedly. Okay, so from here it will be now changed to 3 comma 3, so this will be changed to 3, and again call is made, so 3 comma 3, but 3 is not again greater than 3, so we'll say print 3. Okay, so from here 3 will be printed, and then this will be changed to 4, right? So it was 3, but now it is changed to 4, and 4 comma 3 it will be called. So now I will be greater than 3 in the next function call, right? So here 4 is greater than 3, and so we will say this is true. So we will say return. Now no more function call should be made because we are crossing the limit now. Okay, so we'll again return. Okay, so we'll return here where we have left. Okay, and there is no further function call, so we'll again return here. Okay, there is no again nothing left here, so we'll again return here. Okay, then we will again return here, right? So stack unwinding will take place. Okay, as we have seen in the previous video, right? So again, how many function call are being made here? So total n plus 1 function call are being made here, right? For n equal to 3, there are total 1 2 3 4 function call are being made. Okay, and if we talk about n equal to 4, then there will be total 5 function call will be made. Okay, one more time function call will be made. Okay, and for n, total n plus 1 function call, and in each of the function call we are doing this work. Okay, just comparison. Okay, in each of the function call we are doing this extra work of comparison before calling the printf function. Okay, or sorry, print function. Okay, print method. So basically this work can be done in 1 unit amount of time. Okay, as we used to find the time and space complexity. So this is of order of 1. So if we talk about time complexity, it will be total number of function call, okay, into the time taken in each function call. So this is n plus 1, and this will be basically order of n. Okay, and again, how many maximum number of function call can we place on the stack after we execute this program? Total n plus 1 function call are being placed on the stack. Okay, so this space complexity will again be order of n plus 1, which will basically be order of. So if we take stack space into account, then space complexity is order of n. And if somebody say, if you remove this space of the stack, okay, if you do not assume this space into the space complexity, then what will be the space complexity? Then it will be order of 1 only, that is constant space, because other than stack there is no extra space being taken by your code. Okay, now in this question, if you want to print natural number from, let's say, from 2 to n, then what should be the change in this code? So basically only this starting value has to be changed. Now I want to start the value of the I, okay, from 2. So 2 comma n should be sent. Okay, and this code will work fine. Okay, and if I want to print, let's say I equal, and if I want to start the natural number printing from, let's say 5, okay, 5 to n, let's say n is 20 and I want to print 5 to 20 natural number, then I will call from here 5 comma n. Okay, starting value has to be changed. Okay, now let's see how we can write the code for printing the natural number in descending order from n to 1. So basically for this question, what I want, if n is 3, then I want to print 3 to 1. If n is, let's say 5, then I want to print 5, 4, 3, 2 and 1. Okay, so same answers but in the descending order. Okay, so how we can do that? So basically we know that this is the final limit till which we have to print. Okay, this is the limit that we are you can say we do not have to take from the user. This we know, and we also know the starting point. Okay, we have to start from the n. Okay, so from n to 1. Okay, this also we know, this also we know. Okay, actually this type of question can be done by passing only one parameter. Okay, that is from the main function I will just call the function using the n only, and I can do this question. I do not have to send two parameters. Okay, and I can do this using the two parameter obviously. Okay, so first let's see how we can do this using the two parameter, and then I will tell you how we can do that using single parameter only. So basically in this code again we have to do a repeated work. What is the repeated work? Repeated work is printing. Okay, printing again and again, again and again, right? So for this printing we will make a function called print, right? So this will be like recursive function call, recursive call, and there will be stopping condition. Okay, stopping condition will be when this printing will reach, you can say 1, we will print, but when it will reach 0, then we will not print. So this is the stopping condition, right? So the thing is we have to formalize what will be the parameters here. Okay, so we have the input n, right? So we can actually start from the n, right? And we can just start printing. Okay, and we will say when this n will reach 0, then we will stop. Okay, so let's see what is this method. Okay, just by using one value of the n can we print. Okay, then I will tell you the next example where we will print this n to 1 using the two parameters. Okay, in this stack how the function call will be made. So first print of 3 will be called, right? So from the main this 3 will be called, that is n is 3, right? Okay, and now 3 is equal to 0, no, so we'll print n. Okay, so first time we will print n as 3. Okay, then we will decrement, so this will be 2. Okay, so here it will be 2, and print of 2 will be called, here n will be changed to 2, and now 2 is equal to 0, no, so we'll print n, that is 2. Okay, and then we will decrement, so this will be decremented from 2 to 1. Okay, and in this same function call this parameter will be changed to 1, and now print of 1 will be called, here 1 will be sent, and now 1 is equal to 0, no, because we have to print, so cout n, that is 1, and after that we will decrement this value of n to 0, so this will make 0. Now print 0 will be called. Okay, now when n is made 0, now we have to stop because we do not have to print 0, right? So we will say when n reaches 0, n equal to 0, we will return. Okay, so we'll say in this function call n was 0 but will not go up. Okay, we'll simply say we will return, so we will return to the previous function call. Okay, so previous function call means we are actually going from here, this statement, to every function call. Okay, so when we will return, then we will come to the next line after this function call, and there is no other statement after this function call, so we will simply return by seeing this end of the function. Okay, so we will simply return. Okay, we will simply return. Okay, and finally we will come to the main function. Okay, so basically in this code we are printing the answer while going up in the stack binding process. When we are returning, okay, from the function call, then we are not printing our answer. Okay, but in some of the problem we'll see when we are returning, then also we have to do some work so that we can find our final answer of our given question. Okay, so after this line also we can do some questions, or you can say some of the statement we can write here. We'll see in the next videos. Okay, now before ending this video, can you write this code using the two parameter? That means if I send n comma, okay, n is the starting point from where we want to print, and the ending point is you can say 1, right? So if I say n comma 1, then we have to write 2 parameters here, and then we have to write 2 parameters here. Okay, and then can we write this code? So basically this is the code. Here I am saying n comma 1. 1 is the final limit till which we have to print. Okay, and n is the starting point from where we have to start, n comma 1. So here n, okay, and this is like int I. Okay, so I is receiving 1 and this is n. Okay, so we have to print, okay, again and again the value of the n. Here you can see, okay, n will be decremented. Here you can see as previous we are decrementing n. Okay, and we are just passing this value of the I. Okay, I will remain as 1. Okay, so I is, you can say, ending limit. Okay, so we are saying I will be like this one. Okay, so whenever the value of n, okay, it is getting decremented, it is lesser than I, okay, or equal to I, then we will print this. Okay, cout n will be printed, okay, when n is greater than, okay, or you can say equal to I, then only it will be printed. Okay, but if n is less than I, okay, n will be decremented to this. Okay, n was this, but when n will be decremented to 0, okay, n will be lesser than I, then we will stop. Okay, so this is one of the other method also. Okay, but here, as you know, that it is not mindful or intellectual, but here you know that this is not a good decision to take the extra parameter 1. Okay, because we can do this problem using the single parameter. So if you can do the question using single parameter, it is very good. Okay, so the first method will be better. Okay, this method is also okay, but try to do in the lesser number of parameter if you can do. Okay, so yeah, this was all about this video, and I hope you can now very well understand that how we can write the recursive code. Okay, or you can say the recursive function code, how we can think. Okay, so let's see, in the next video we will discuss more of the problems based on the recursion, like finding the factorial, linear search, some of the digits of a number, and various other problems. So do like, comment, and share this video, and please do subscribe the channel and press the bell icon for the notification of the video. See you in the next video. Till then, goodbye.